Good morning, students. Today I'm going to solve one NEET based question. This question is raised by my student. One of my NEET student raised this question. Okay, I will solve this one. Before solving this one, you please solve this. Pause this video. You please try to solve and get some answer because I have given the choice also. You please check whether you are getting the answer or not. After finishing this question, then only you have to check this video, please. Because without solving any question, without trying any question, if you are seeing the video, if you are seeing the solution, whatever may be, wherever, if you are checking the solution, then you may understood that yes, we can able to solve this one, like that you may understood. But this type of question could not be solved by you again. That is the main problem for every student, because you are seeing only the solution, you are not at all finding the method. The method will help you to solve any question based on this type, any critical question. If you want to solve the critical question, please pause this video here and try with your own way, and then please come to the video and check whether my way is right or your way is right, whether you are getting the right answer or I am getting the right answer, like that you please check that. And then one more thing, you may find some easy method. Sometimes you won't get any answer by seeing the formulas, and after checking the book you won't get any answer. You have after you are analyzing that question also, you won't get answer, means you should be very happy, because you have analyzed more concepts that will help you in future. But without trying, if you are directly solving this question, it will not help you anymore. So please keep it in mind. Pause this video here and solve this question and then come to my video. Okay. Yeah. So first of all, in the solution lesson, this question is asked in the solution lesson, based on the solution lesson. So Henry's law constant for oxygen and nitrogen are given. And then calculate the ratio of mole fraction of O2, mole fraction of N2. Sometimes you students may say, ma'am, I even know, I don't even know the formula itself. Then how can I try with my own way? Like that you may think. Please don't think like that. Just take a book and please see the formula and then work it out. Okay. So actually we are having the formula of Henry's law concept, right? Uh, First, in the solution lesson itself, that there will be a 9 types of solution. After dealing that 9 types of solution, we will analyze the first solution based on gas in liquid. So what is the Henry's law? Partial pressure of gas will be equal to Henry's constant and the mole fraction of that particular gas in liquid. Please look at this here clearly, because we may have the mole fraction in the gas phase also, because when you are having a liquid, that liquid can produce A particles in the vapor phase also. So in the vapor phase, some other particle may also be there, B particle and C particle may also be there. So vapor is also having mole fraction of A, and liquid is also having mole fraction of A. That's why you should be very careful. So here I am mentioning the mole fraction of that gas in liquid. Mole fraction of gas in particular liquid. Mole fraction of that gas in liquid. Remember this one. And the partial pressure of the gas determines how much gas will be dissolved in the solution. So partial pressure of the particular gas, if you want to dissolve the carbon dioxide in water, then you should maintain the carbon dioxide pressure alone in the air. If you are maintaining the whole pressure, again the whole thing will be there. But so if you want to give the carbon dioxide alone in water, then you should maintain the partial pressure of carbon dioxide. For example, just I am applying that for carbon dioxide, partial pressure of carbon dioxide will be equal to Henry's constant for the carbon dioxide and the mole fraction of the carbon dioxide. Okay, then we will check what they are asking. First of all, whenever you are seeing the question, you have to understand, you have to understand that what are the given data and which has been asked in this. So here the given data are Henry's constant for the two gases, and then they have given the mole fraction indirectly. So I'm going to find out the mole fraction of this two gas, and they have asked the ratio. Then you can find out easily from the formula, right? Look at this, partial pressure of N2. So here the numerator is O2. That's why I'm going to take this as O2. So partial pressure of O2 will be equal to Henry's constant for the particular oxygen and the mole fraction of that oxygen divided by partial pressure of nitrogen that will be equal to kh and Henry's constant for the Henry's constant for nitrogen. So I am going to take this as kh dash. So x of O2 and N2, and we know that partial pressure, actually we don't know about the Henry's sorry, yes, we know the Henry's constant there that they have given, and we can get this one. Which one we can get? The mole fraction we can get here. What they are saying, oh okay, actually we couldn't able to get that mole fraction because here dissolved in water at 25 degrees Celsius, assuming that air contains. So here they have given the percentage of nitrogen and percentage of oxygen in the air only. They didn't give any clue about the mole fraction of nitrogen and oxygen. So let us check that one. So partial pressure of oxygen. First, they have given the clue about the partial pressure of oxygen, but actually I said initially they have given the clue about the mole fraction, right? Students, whenever I'm solving the question, I won't see that before. Directly I will enter into the video. Why I'm doing like that? Because whenever you are approaching the question, you should be feel fresh. Then that is you will be fresh, right? The student will be freshly felt about that one, because they won't analyze that particularly again and again, and then they will not come and solve the question. So I have to get the fresh feel, then only I can able to go into the student's mind, and I can able to solve with student mind. That's why I'm taking like that. That's why I'm explaining that one. Because I have given the wrong information about the 80% and 20% by volume as a mole fraction of nitrogen and oxygen, right? Actually that is the clue for the partial pressure of oxygen and partial pressure of nitrogen. Okay, let us check. What is the partial pressure of oxygen? They both of them are in the percentage. Then not necessary to worry about the conversion factor. That is ma'am, pressure means it should be in atmosphere. Pressure should means it will be an definitely Pascal. Like that, not necessary to think, because we are taking the ratio, right? Both the unit will be cancelled here. Here you should remember only. You should take the two units in a same manner. For example, the partial pressure of oxygen is 20% of 20% by volume. So the unit is 20, sorry, unit is percentage. So I am taking 20 divided by partial pressure of nitrogen will be 80. You might think, directly we can apply that one. Why you are considering like this? Why you are confusing like this? You may ask me. But actually here why I am doing this one, because sometimes they will ask the partial pressure of, they will give the partial pressure of oxygen in Pascal, partial pressure of nitrogen in atmosphere, like that they may think, they may give. So in that case you should use the proper data, that the proper units. That's why I'm explaining that one. So 20 divided by 80, and kh, the Henry's constant for this one, 3.3 into 10 to the power 7 and 6.6 into 10 to the power 7. So 3.3 into 10 to the power 7 and 6.6 into 10 to the power 7. Let us check whether, yeah, wait a moment. Actually, 10 to the power 7. Yes, everything is right. And then mole fraction of oxygen and the mole fraction of nitrogen. So we need this ratio. So if you are cancelling this one, this will be 1 by 2, and then you will get to the you will get that 40 divided by 80. So the answer will be 1 by 2, but really it will be 0.5. Yes, yes. So we will get the ratio as 0.5. And you should be very careful on the constant unit. But here the constant unit also, because we have taken the ratio, that's why the constant unit also will be the same. Why I am asking you to be control in the unit of, that is Henry's constant unit, because in some JE question, they will reverse the formula. JE advanced question, they will reverse the formula. That's why I asked you. But anyway, this is the kind of solving this question. I think this is very, very easy, right? Thank you, students.